So then to end, so this is the action potential, the Martini slides. Don't worry, they'll be up later. But now you know why action potentials and travel along an axon. It all involves ion channels, and it's more specifically those voltage gated ion channels. Now let me flip through this for time's sake. So here we have two axons. So this is an axon up here. This is an axon down here. So here we have a plasma membrane. It has all these ion channels. So when you open one ion channel, the change in membrane potential and the positive charges opens the next and neighboring ion channels. So this is how an action potential is able to propagate. A change in the membrane potential due to one ion channel opening changes the potential enough that causes neighboring ion channels to open, which causes a domino effect. And this is how you pass along an action potential along a membrane. Now, the thing about the myelin, so why do we have all that myelin surrounding axons? Well, the thing is that you don't need, what we have here is that we have ion channels, but when you have myelin covering these plasma membranes, you don't need ion channels there. There's no room for them. But the cool thing about these myelin sheaths and these nodes of Ranvier is that when you have an ion channel open, or actually this above example, rewind a bit, sorry, is called continuous propagation. So it's kind of like it's just like neighboring all these dominoes falling. Like, have you ever seen those cool videos where they have a bunch of dominoes stacked and they kind of trigger each other to fall until they form these cool patterns and chain reactions? That's continuous propagation. But nodes of Ranvier, what happens here? So the thing is that when these channels open, just this change in membrane potential can actually pass along and jump from this channel all the way to this channel. So what we have is here is fewer ion channels opening, but you don't need all those ion channels in between when you have this type of propagation and action potentials being passed. This is what we call saltatory propagation. So if you think like a somersault is a type of jump, so what it's referring to, I think salto is actually a Latin root word meaning jumping. So this action potential actually jumps between the myelin node or the nodes between myelin. So why? Because again, you don't need as many channels opening, so it's kind of faster. If this channel can detect this channel opening, this channel can detect this channel opening, and the myelin kind of like shortens the amount of chat time it requires fewer ion channels to open, and it's also faster because you don't need to go between all these middle channels right here. Or I was trying to find a really good video of it, but I forgot. I think it was the last Lord of the Rings movie. But do you remember that? If you've watched it, do you remember that scene where they're lighting these fires on these mountaintops? And when one person sees a fire on a mountaintop, the next person lights the fire, and word of like rallying all the armies comes together by lighting these fires. That it passes way quicker because again, they're seeing these smoke signals and fire signals from fire to fire. So saltatory propagation is kind of like that. You're sending signals across long distances. Whereas continuous propagation, pretend those people didn't have those bonfires on the mountains, and they had just had to use like word of mouth and telling each other like they're like a human like kind of communication network or a game of telephone. That would be way slower than laying those mess signal bonfires. So that's another analogy I like to do. Okay, so we're out of time, and I know it's action potentials. If you didn't get, if it totally missed you, don't worry. The first time I learned action potentials, oh, I didn't get it at all. It is very abstract. I noticed it's probably one of the hardest topics in this whole semester because it's very theoretical, lots of chemistry, lots of cell biology. So good thing is that I'll try to edit this and get this up online as soon as possible. And heck, you have still what 5 weeks left? I mean, still we have like over a month before the final. So again, if you didn't get it the first time, just review things, or there's a review session as well. Oh, and my announcement. So again, so many things to worry about. I mean, this. I mean, I think everyone's distracted by nationwide events right now. So again, pack back this week is a makeup week. So everyone has 125 points by default. If you want to work ahead or make up for lost points, if in case you missed some weeks, you can use this week as a makeup week as well. Same like it was during exam two. Again, I think I don't want people worrying about pack back during this week. I understand a lot of people are distracted right now, so don't worry about that. So if you want to take the week off, I mean it. Like even if you want to take Friday off, by all means, you can take it off as well, all right? Okay, so until then, take care, stay healthy, and I'll see you on Friday, all right?